So we're looking in section 8.4, which is about a topic called annuities. Now, what is an annuity? Well, annuity consists of a series of payments, or you could say deposits. So you have a series of payments or deposits made, and these payments are going to collect compound interest over time. Compound interest over time. So there are different types of annuities. You can pay different amounts of money every period. Let's say, I don't know, like at the end of every month. But we're going to do an annuity where you just pay the same amount at the end of every compounding period, which usually will be at the end of every month, but not necessarily every month. Sometimes it'll be every quarter or every year. So that's what an ordinary annuity is. An ordinary annuity, and that's just an annuity where fixed payments. So by fixed payments, we mean it stays the same amount every compounding period. You don't change the amount of the payments or the deposits. You don't change the amount, so it's always the same. So an annuity where fixed payments are made at the end of each compounding period. So not at the beginning, but at the end. So maybe at the end of every month, maybe at the end of every year, maybe at the end of every quarter. So that's what we're going to focus on. These kind of annuities where we pay the same amount at the end of every month, every year, every quarter. So we want to show you what's the future value formula. Future value formula for an ordinary annuity. So I want to motivate this with just kind of an example before I write down the formula. So here's the idea. Let's draw a timeline. So down at the bottom, I'm going to have time. And maybe this is in months. We have like 0 months, 1 month, 2 months, 3 months, 4 months, and so on and so forth. 5 months. And then we have our last month here. I don't know, we'll call that 24 months. Okay, so this would be like over a 2-year period, and these are months. And let's say you have some payments that are being made. So up here you have money. And let's say at the end of the first month, I get paid, or let's say I take $100 and put it in a bank account, $100. And the end of the second month, $100. And so on and so forth. $100. So at the end of each month, $100. Until I get to my 24th month, and at the end of that month, I'm going to pay $100. Now, when you pay $100 at the end of the first month, over the next 23 months, it's going to accumulate interest. It's going to grow, right? That money's going to grow. And also, the money that you pay at the end of the second month is going to accumulate interest. And the money at the end of the third month is going to accumulate interest. And this continues. For all of these months, you're going to accumulate interest on those $100 payments. Except for the end of the 24th month right here, right? You're not going to accumulate interest because you're right there at the 24th month. But all the other months are going to accumulate interest. So you're going to have a grand total here, which we're going to call the future value. Future value of this annuity. So this is an ordinary annuity, right? You're paying a constant or a fixed amount of $100 at the end of every month. And this is going to accumulate to a certain future value. And that's what we're interested in. We're interested in what is this future value? What is this total amount that our money is going to accumulate to with interest included? So that's what we're doing here. So the formula we're going to use for future value, we're going to use the letter A for future value equals capital R times 1 plus little r over m, parentheses around that to the mt, and then subtract 1, and then that's all over little r over m. So capital A, that's the future value. What is future value? It's the total amount that the account is worth at the end of the period. So the final amount after time passes. Capital R, that's the amount of your monthly payment or your regular payment amount. So not necessarily monthly, it could be yearly or could be quarterly, regular payment amount. So capital R for regular payments. So when we were looking at this little example below, our capital R would have been 100 because we were paying in $100 at the end of each month. Little r is going to be your annual interest rate. That'll be given in your problems. Little m, that'll be the number of times per year that you're making payments. So number of payments per year. Number of payments per year. Let's put it that way. Number of payments a year. That's the good way to say it. Number of payments per year. And t, little t, that's the time in years that goes by. This is a formula you want to be using here. The future value for an ordinary annuity. So we want to work some examples. Okay, so here's number 1. If $200 is deposited quarterly, that means at the end of every 3 months, so that's 4 times a year, in an ordinary annuity, with an annual interest rate of 5%. What will the value of the annuity be, after, let's say, 10 years? So we know we're dealing with an ordinary annuity, right? We're told that. What will be the final value? What will be the value of the annuity? That's the final value. So this is the future value. That's capital A we're looking for. So we're going to use our formula. Capital A equals capital R times 1 plus little r over m, and raise that all to the mt, where t is the time in years. And after we compute that, we'll subtract 1, and we'll divide that all by little r over m. So let's see, what is capital R here? We're looking for big A, right? Big A, the future value, the value after 10 years. So capital R, those are our regular, in this case, quarterly payments. Right, $200 is deposited quarterly. So $200. What else? Little r is the interest rate, the annual interest rate. That's 5%, 0.05. So little r is 0.05, 5%. What else? M, how many times a year are we making deposits quarterly? So M is quarterly, 4. And T, that's the number of years. T is going to be 10. So I'm going to plug this into my formula. If you want to plug this all in the calculator at once, you get more accuracy. I might break it up into a few steps here. So let's say I got the big parentheses after the 200. I got 1 plus, let's see, 0.05 divided by 4. We're going to raise that to the 4 times 10. After we do that, we'll subtract 1, and then we'll divide that by, let's see, 0.5. No, it's 0.05. So 0.05 is the green. .05 over 4. In other words, what we're calculating this future value, it's going to be 200 times. So I'm going to take 0.05 divided by 4 here. 0.05 divided by 4. Let me see, calculator. 0.05 divided by 4. I got 0.0125. So that's going to give me in the parentheses 1.0125 raised to the, let's see, what's 4 times 10? 4 times 10 is going to give me the 40 power minus 1. And then we're going to have to divide that by, well, 0.05 divided by 4 on the bottom is going to be 0.0125. Let's see if I can write that a little better, 0.0125. So I'm going to plug this in my calculator. Now, when I plug it in my calculator, the black number, I'm going to leave the 200 alone. The blue 200 alone. And I'm going to put this in my calculator. When you're putting in your calculator, probably you want to put parentheses here around the top and then do a fraction and divide 0.0125. So if I were doing it in my calculator, I'd do it like this, probably. Parentheses is the way you type it. 1.0125 raised to the parentheses 40, close parentheses, minus 1. Oh, I should first, okay, let me go back. I should put parentheses around all that first. So let me do that back over again. So when you're doing a calculator, well, you want to put parentheses, and then parentheses 1.0125, caret to the 40th power. Some calculators might require you to put a parentheses around the 40, then minus 1, and then close a parenthesis after minus 1, and then the fraction division bar, and then 0.0125. If you do that on your calculator, you should get about, let me actually do it in my calculator. Let's see, parentheses 1.0125, close parentheses to the 40, minus 1, close parentheses divided by 0.0125. So when I did that in my calculator, I got 51.48. But let's take it to 4 decimal places. 51.4896, just for accuracy's sake. So then we're going to multiply that black number by the blue 200s and multiply that by 200. And you should get pretty accurate. The future value of that annuity will be $10,000, $10,297.91, rounding to the nearest cents. So yeah, so if you put in $200 every 3 months, at the end of every 3 months, for 10 years, you'll have a little over $10,000 saved up. That's including the interest that you get from a compounded interest situation. All right, let's do. Okay, we'll just do the next video. We'll stop.